only if C is not an endpoint. All right. So either this is true or that is true, or C might be an endpoint. There's another possibility that you need to consider. Okay. So or C is an endpoint. Right? In other words, C might be A or B. If C is an endpoint, what does that mean? That means absolute maximum is at the end. Which picture would that be? It's right here. This is the picture for which absolute maximum is at the end. And when that happens, how do you get the C? You just take an absolute minimum. Okay. So in this case, you got to conclude. This case cannot happen. For this case, you just retake C. You take a different C. You take absolute minimum instead. And you call this FC1 maybe. Okay. Well, because so then this cannot be A or B. It cannot be endpoint because it's absolute minimum. Because FA, FB are already at maximum. So C1 has to be inside. So then you apply what we said before. Then we get, so C1 must be inside. Therefore, F prime C1 must be 0. Okay? It has to exist. So this case cannot happen. So it has to be 0. You can think about this. The proof again. That is the idea. Okay. Let's look at the general mean value theorem then. So let's call this to be theorem 2. Theorem 2, mean value theorem. Mean value theorem. Okay. So for the general statement of mean value theorem, you do not assume FA equals FB. Instead, you just erase it, and you have the same condition, which is F is a frank continuous on the closed interval, differentiable on the open interval. Okay. So I'm going to erase this. Then you would like to say there is a C such that so and so is true. Well, do you still expect F prime C to be 0? Well, it is differentiable every inside F. So we do have F prime C that is defined everywhere inside. So the picture would not be something like this. It may well be something like this. Let's try to imagine the picture then. So instead of this picture, you would like to have reset. You would like to have a picture like that. Something like this, for example. This is the A, this is the B. I mean, obviously, you can no longer expect F prime C to be 0. Well, what you can say is the following. If you connect at the beginning point, which is A, the end point, which is B, you have a secant line like this, from A to B, right? And then what you can prove is that there is some C such that F prime C is the same as the slope of the secant line. In other words, the tangent line here is going to be parallel to the secant line, AD. So that's the statement. So there is a C such that the tangent line at the C is parallel to the secant line, AB. Okay. Now, when I say they're parallel, remember that two lines are parallel if their slopes are the same. Therefore, parallel means that the slope of the tangent line equals the slope of the secant line. What is the slope of the tangent line? That's just the derivative, right? So being parallel means that f prime c equals to the slope of the secant line. What would be the slope of this secant line then? Well, let's think about this. A has a coordinate which is what? X equals A, and what is y equal to? Right, f of A. Because it's on the graph. And for the point of B, x equals to B, and y equals to fb, right? Therefore, what should be the slope of the secant line? fb minus fa over b minus a, right? So all right, that's the statement. So instead of saying f prime c equals 0, we're going to say f prime c equals to fb minus fa divided by b minus a. Okay. Another way to put this equation is the following. I.e., I is a better word here. This equation is obviously the same as fb minus fa equals what? Equals to f prime c times what? B minus a. Those are obviously the same equation, right? Equivalent. So you can state your mean value theorem in this format. Let's draw a few pictures and see if we can be convinced that this has to be true. So for this picture, it looks like a C is here. You can draw a few more pictures. Okay, FA, FB. I mean, you can draw a picture that way rather than below. I mean, it's still the conclusion is true, right? It looks like, so this is your secant line, this is the tangent line, so this is your C here. You can even draw a picture that goes up and down. So A and B, something like this. And the conclusion is still true, right? This is the secant line, and you get even two solutions for C. 1 and 2, right? It seems like it's always true. Let's look at an example. Let's let fx to be let's try to find minus +1. Verify the mean value theorem. Let's say this is defined on -1 to 2. Verify the mean value theorem. Okay? What does that mean? We're trying to find a C such that f prime c is equal to this expression. So, what do we do here? We just have to, we want to see such that f prime c equals to fb minus fa over b minus a, right? So let's just work out the algebra. Right hand side should be equal to, what is that, f2 minus f minus 1 divided by 2 minus 1, right? Okay, so let's do the computation here. What is f2 equal to? You can just do it on the side. f2 equals to 2 to the 3, that's 8, minus 18 times, 8 times 2, 16, plus 1, so minus 7. All right. You substitute the minus 1, you get minus 1. That's going to be plus 8, plus 1, so that's 8 here, divided by 3, and that is equal to negative 5. What we got? Yes. Negative 5. Let's do the left-hand side and solve them to be equal. F prime c, that is 3 times c squared minus 8. Are you with me? You take the derivative, you get a 3x squared minus 8. And because we're talking f prime c, so that's, you want them to be equal. So 3c squared minus 8 equals to minus 5. C squared equals to, 3c squared equals to 3. C squared equals to 1. So, are we saying c equals to plus or minus 1?
Yes.
I'd like to say that, except I think the theorem really says that you can always choose the c such that the c is inside the interval. So just to throw away c equals to minus, because minus 1, it happened to be on the end, right? So remember you want the c to be inside the open interval AB. All right? And negative 1 is on the boundary, is the end point. So you throw away c equals minus 1. So just write c equals minus, c equals plus 1 is the only solution. That's the only solution for this problem. So c equals minus 1 is, notice c equals minus 1 is end point. So we just copy that, we throw that way. Okay. You want to do an exercise here? Okay, let's do a cross exercise. X is equal to 2 x to the third minus 12x plus 2, and define on the interval to 4. You want to find the C of that meets the condition of the mean value theorem. Okay. So give me a few minutes of that.
It is.